Hello everyone, we are from Group 4 and we will be presenting about principal communications to you guys in simple terms. So my name is Haris and I will begin my presentation. So the list of contents that we will be talking about is what is 5G technology, type of modulation technique, benefit and impact of 5G, misconception regarding 5G and how to resolve the misconception. So what is 5G technology? 5G is the fifth generation of wireless network technology. It offers faster download and upload speeds and allows for more connected devices at the same time. So there are three types of modulation technique. The first one is amplitude modulation, the second one is angle modulation, and the last one is radio modulation. So amplitude modulation is a technique in telecom where the amplitude of a high frequency carrier wave is varied in accordance with the information signal, which can be an audio, video, or data signal. The principles of AM are embedded with more complex modulation schemes such as quadrature amplitude modulation (QAM), which are extensively used in 5G technology. Um, AM also allows 5G networks to deliver high-speed data transmission and robust communication by dynamically adapting to varying channel conditions, ultimately enabling seamless connectivity. So there are applications of AM such as radio broadcasting and two-way radio communication, aviation and maritime communication. So angle modulation, the definition is angle, phase or frequency of a carrier wave is varied according to the information signal. There are two types of angle modulation. The first one is frequency modulation (FM) and also phase modulation (PM). For frequency modulation, FM varies the carrier wave's frequency in proportion to the instantaneous amplitude of the modulating signal information signal. The basic concept of FM, instantaneous frequency. The carrier frequency changes in real time according to the amplitude of the modulating signal. Modulating signal, the input signal dictates how much the carrier frequency deviates. So there are many applications of FM. The first one is radio broadcasting, which is widely used for FM radio due to better sound quality and less susceptibility to noise. The second one is television audio. FM is used for audio portion of analog TV broadcasts. And the last one is satellite communication, employed in satellite transponders for robust and efficient data transmission. And the other one is phase modulation. The meaning of PM is a technique where the phase of the carrier wave is varied in proportion to the instantaneous amplitude of the modulating signal. Phase variation, the phase of the carrier wave changes according to the amplitude of the modulating signal. And constant frequency and amplitude, the frequency and amplitude of the carrier wave remain constant, only the phase is varied. Application of FM, first one is digital communication, which is widely used in uh, modulation schemes such as phase shift keying (PSK), including binary phase shift keying (BPSK) and quadrature phase shift keying (QPSK). For radar systems, PM is employed in some radar systems for better resolution and target detection. For telemetry, PM is used in transmitting data from remote or inaccessible points like spacecraft. And now we move to radio digital modulation. Um, Digital modulation involves encoding digital information onto a carrier wave by varying its amplitude, frequency, or phase. The purpose of it is essential for transmitting digital data over radio frequencies in modern communication systems. So now I will pass down to Haziq to continue the rest of the slides.
Assalamualaikum. My name is Aziz Fadilah bin Hadi, and I will continue to the type of digital modulation. It is consists of four, which is amplitude shifting king (ASK), frequency shifting (FSK), phase shifting (PSK), and quadrature amplitude modulation (QAM). For the amplitude shift king (ASK), the concept is binary data represented by different amplitude of the carrier wave, and the application is used in simple and short range communication system like RFID. So when there is amplitude in the wave, it will the digital value is will be one. When there is no wave, this means it will become zero. For the frequency shifting FSK, the concept is binary data represented by different amplitudes of the carrier wave, and the application is simple, which is used as a short range communication system like RFID. So when there is a frequency which is high frequency, the digital value will be 1. When the frequency is low, the digital value will be 0. The next one is phase shift keying (PSK). The concept is binary data represented by different phases of the carrier wave. The variant are binary PSK, quadrature PSK, and high order PSK. The application is widely used in wireless communication and satellite, which also same with the others shifting, which is for RFID. So when the wave is same with the previous wave, the digital value will be 1. When the wave is continue like a previous one, it will toggle and it become 1. The last one is quadrature phase shifting QPSK. It have 4 debit, which is 11, 01, 00, and 10. For 11, the phase is 45 degree, 01 is 135 degree, 00 is 225 degree, and the 10 is 315. As you can see in the graph, it can be shown that 11, 01, 00, 10 can be put to angle term, which is 45, 135, 225, and 315 angle. What is QPSK? The definition is quadrature phase shifting is a digital modulation technique where the phase of the carrier wave is varied to represent digital data. QPSK change from 45 degree, 135 degree to 25 degree to 315 degrees. The code used in QPSK is secret code. So the next one will be application of the 5G. It widely used in wireless communication system, satellite communication, and other digital communication applications. And the impact and benefit of the 5G, it enhanced the connectivity and communication, high data speed and low latency. The second one is Internet of Things, IoT, and smart cities, smart infrastructure, and massive IoT connectivity. The third one is economic growth and innovation, job creation, and business transformation. The fourth one is healthcare and telemedicine, high quality of healthcare and access service. The fifth one is education and remote learning, digital learning and access to education, enhance public safety and emergency service, which is critical communication and disaster management. Sustainable development, which is energy efficiency and smart environmental monitoring. The last one is entertainment and media, which is immersive entertainment experience. And to the next one is means conception of 5G among society. There is four type, which I will present each of them one by one. The first one is health concern. The misconception among the society is the 5G causes significant health risks due to increased radiation exposure. The analysis is radio frequency (RF). The exposure is 5G, like previous cellular technologies, use RF electromagnetic field, which the World Health Organization (WHO) and other health authorities have conducted extensive research and conclude that RF exposure from 5G is well below the safety limit. So the result of this misconception, regulatory regulatory compliance, which is government and regulatory bodies set stringent safety standards to limit RF exposure level. 5G network must comply with this standard to ensure public safety. The second one is safety concern. The misconception is the 5G small cells and antennas pose safety risk to the public. The analysis is antenna design and placement, which, for example, the 5G network rely on small cells and antennas placed closer to user for improved efficiency and coverage. Concern arise about this potential exposure to RF radiation. So the resolution for this misconception: public awareness, where they're educating the public about RF radiation and addressing concern through transparent communication about safety measure and compliance. The third one is legal and regulatory issue. The misconception for this issue is 5G deployment face legal challenges related to property right, privacy, and regulatory compliance. For this analysis, the privacy concerns, which data privacy issue arise due to the increased volume of data transmitted over 5G network. So the resolution for this issue: stakeholder engagement, where they're engaging with stakeholders including communities and property owners to address concerns and ensure transparent and communication about deployment plans and regulations. And the last one is cultural and social implication. The misconception is 5G adoption will exacerbate digital divide and cultural disparities. The analysis for this misconception: digital divide, where the concern that undeserved or rural area may lag in 5G adoption, widening the digital divide. The cultural impact: the integration of 5G technology may impact cultural practices and norms, raising the question about cultural preservation and adaptation. The resolution for this issue is inclusive deployment, where the government and telecommunications provider work to ensure equitable access to 5G networks, including undeserved areas, through targeted deployment strategies and subsidies. The cultural sensitivities for this issue: it must be considering cultural implication in 5G deployment, respecting local customs, and adapting technology to meet cultural needs where appropriate. That's all for us. Thank you.